anybody else. So I didn't like what was there, and because it was just too much. And so I actually went back to the last time I taught pre-cal trig and pulled my notes from COVID. So this was COVID. All right. This is my favorite stuff. This chapter is on trigonometric equations and identities. You guys will like the equation solving because it's just solving equations. So we sort of mix that in, so it's solving, but they're trig equations, so it adds a little element there. And we are going to be doing some identities to help us through that. Now, an identity is like 1 equals 1. It's just always true. And so it comes from stuff we already know a lot about. So here, we're going to talk about the reciprocal and quotient identities. I have a really giant angle here. And we already know some of the reciprocal identities. For instance, we know that cosecant of some angle, cosecant is the same as 1 over sine. Yeah, you already know that. Okay. And just so I can show you why, I have this giant triangle here, which clearly didn't need to be that big. We'll pretend that we have some angle theta here. So this is our angle theta. And I have my little right triangle right here, and it's going to be a 3, 4, 5 triangle, okay? And just to convince you that cosecant of some angle is the same as 1 over sine, we're going to do the math. If you'll remember that we have TOA. So cosecant we think of as just the, oh, you can't see that, sorry. There we go. I wrote SOHCAHTOA up top. So cosecant, according to our angle, cosecant would be, excuse me. I was thinking cosecant would be hypotenuse over opposite, right? Okay, so there's a hypotenuse. Here's our opposite side. So it would be 5 over 4. But we're kind of curious, does it really match 1 over the sine? So sine we know as opposite over hypotenuse, so 4 over 5. Well, I don't like dividing by a fraction. What do we do instead? Multiply by the reciprocal. So it becomes 1 times 5 over 4, which is, of course, 5 over 4. All right. So that is absolutely true. So we have these lovely reciprocal identities. And the other ones are, yeah, it is 5 over 4. Yeah, sorry. I busted out my nice pens, my erasables for the last quarter here. Got to keep the interest, you know. Got to add something to make it a little extra spicy. Okay. All right. Okay. So if cosecant is 1 over sine, then sine of theta, then we can also say that sine of theta is the same as 1 over cosecant of theta. Okay. Now, we also know that secant of theta is the reciprocal of cosine, 1 over cosine. All right, and then the reverse is true. Cosine of theta would be the same as 1 over secant. Okay, those are reciprocals. That's what reciprocal means technically, is that it's 1 over something. Okay, and then we have tangent of, I guess I should start with cotangent, but it doesn't matter. Cotangent and tangent are reciprocals. So tangent equals 1 over cotangent of theta, and cotangent of theta equals 1 over tangent. So these are all things that we already know. We're just going to be using them a little differently now, or actually using them. instead of just numbers. Okay, those were the reciprocal identities. We also have quotient identities. All right, the quotient identities, what is a quotient? To a division problem, yeah. So the quotient identities we used for like tangent. Well, tangent turns out to be sine theta over cosine theta. Again, I want to prove it to you using actual numbers. Let's see. So we're going to use our little triangle here to kind of prove it to ourselves that tangent really is sine over cosine. Let's see. So according to my picture here, tangent would be opposite over adjacent. So that would be 4 over 3. And I want to know, is it the same as sine of theta? Well, sine of theta would be opposite over hypotenuse. So that would be 4 over 5. Over cosine of theta. Cosine of theta would be adjacent over hypotenuse, so that'd be 3 over 5. All right, so we have 4/5 divided by 3/5. What happens there? There's a couple things we could do. We could multiply. We could do 4/5 times 5/3. Sorry. So we could multiply by that denominator, multiply by the reciprocal. And those 5s would end up canceling out. And we, absolutely do get 4 over 3. So they do, in fact, work out. The shortcut there is to say, hey, the denominators of 5, the denominators just reduce. Okay? So it turns out that we have this really nice tangent quotient identity is sine over cosine. And so what would cotangent could be rewritten as? Yeah, cosine over sine theta. Okay, so these turn out to be really useful. In general, we like to say that for our identities, we basically want everything in terms of sine and cosine, usually. It's just really nice to just focus on sine and cosine. So that's the bulk we focus on. You guys are getting a lot of practice with everything. But these are the quotients. How do you remember that cotangent is cosine on top? They both have the C's. Yeah, that's how I remember. Tangent is sine over cosine. That's, I don't know, that one just is out. Oh, how I do it. This is more alphabetical. Alphabetically, QRST. So those are closer together. I don't know. Like the stuff I come up with to remember things, who knows? But tangent is sine over cosine. Okay. So those are easy. All right, I have that same big giant triangle. I need to shrink it, clearly. All right, same big giant triangle here. The Pythagorean identities are all of calculus. They are used all the time, just like the Pythagorean theorem is basically everything. So we have, in my little triangle picture here, we have some angle, that's our angle theta, and then I'm just pretending this is in like the first quadrant, so we have an x value and some y distance up, and then I'm just going to call my hypotenuse here, because it is a hypotenuse, I'm just going to call it r. Okay, so we're going to start with what we know, which is the Pythagorean theorem. So this is what I'm doing, you guys. We're actually going to derive these things. This is the difference between, I like doing it this way, because you never have to memorize anything if you know how we got it. It's actually not that hard. So starting with what we know, in any triangle, what's the Pythagorean theorem? Okay, and according to my picture, that would be x squared plus y squared equals the radius squared, r squared, okay? And that's great. Now, this is a very big triangle, but let's say I want to take this triangle and I would want to shrink it down to fit like a unit circle. Well, then my radius in a unit circle is 1. So what I'm going to do is I'm going to divide everything through by that r squared. What happens when I have r squared divided by itself? It's 1. Okay. Well, that's really handy. And then over here, I can rewrite this as x over r quantity squared. And I can rewrite this as y over r quantity squared. Well, not yet. We're pretending. This is common method is to divide through to get a 1 somewhere. So y over r quantity squared. Now, what I'm trying to get is things in terms of trig functions, sines and cosines. Well, when I look at my picture here, x over r is related to theta. Adjacent over hypotenuse, which is cosine, yeah. Cosine of theta is x over r, adjacent over hypotenuse. So that x over r, I can change it to cosine, because it is the same thing. X over r is the same as cosine of the angle in our triangle here. Quantity squared. Let's see, y over r. Y over r, how does y relate to our angle? Opposite. And y over r would be sine. Yeah, sine, according to theta, would be y over r. So once again, I can take out that y over r, and it's the same as sine, according to our angle theta. And so what we've managed to do was create this Pythagorean theorem, and it is now only in terms of theta, which is kind of interesting. Now, this notation is really never used, okay? But this is what it means. In trigonometry, we write it this way: cosine squared of theta plus sine squared of theta equals 1. So this notation is the same. The whole thing is getting squared, but we're lazy. Having to write all those parentheses is tiresome. So instead we put the two like right in the above the sine and cosine function. So you gotta know what that means. So this is the cosine or Pythagorean identity here. This is the big kahuna. This is the one you really gotta know. But that's pretty easy, right? Cosine squared plus sine squared is 1. It's really nice. Okay, so what we then can do is we can create some others to get our other trig functions in there. We're going to do a couple things. We're going to divide through by cosine squared. So I'm going to take my equation here, which was cosine squared theta plus sine squared theta equals 1. And I'm going to divide every single term by cosine squared. Hello! You're so happy to be in this class right now. I know you all are. Woohoo! Okay. All right. I'm sure you're tired. All right, so we're going to divide every single term by cosine squared. So cosine squared theta, and cosine squared theta. So I can divide every single term by cosine squared. What is cosine squared divided by itself? 1. Magic. What? Isn't that kind of interesting, though? Like here. Okay, and then we have, this is sine over cosine. What is Tangent. Yeah, so what do you suppose sine squared over cosine squared is? Tangent squared. Very good, ladies and gentlemen. Tangent squared. Very good. And then we have 1 over cosine. What's 1 over cosine? Secant. So what do you suppose 1 over cosine squared is? Secant squared. Exactly. Ladies and gentlemen, you just derived another Pythagorean identity. Do you have to know this one? No. You have to know this one. It's easy to get this one, isn't it? Okay. Yeah, the big kahuna is really the one you want to know. But I'll tell you, I had a student one year. I never memorized these. I always knew this one and then just would derive it because it's one step. So easy to do. So I had a student that one year who was like, oh, my teacher used to say, she had a phrase. And the phrase was, 1 adds a tan by the sea. 1 adds a tan by the sea. 1 adds a tan by the sea, Kent squared. Okay, so 1 adds a tan by the sea. Oh, yeah, it's pretty good. I have to say, I have to say it out loud to myself every time I want to think about it, but that's pretty good. Okay, so if I take the big kahuna and divide through by cosine squared, then I get 1 adds a tan by the sea, tan squared, okay? What do you suppose I'm going to do to get another one? Divide by sine squared, okay? So again, I'm going to take the big kahuna, cosine squared theta plus sine squared theta equals 1, and I'm going to divide everything by sine squared theta. All right, what's cosine over sine? Cotangent. So what's cosine squared over sine squared? Cotangent squared, yeah, okay. And what's sine squared divided by itself? You're ahead of me. What's sine squared divided by itself? 1. And then you said 1 over sine was cosecant squared. So 1 over sine squared would be cosecant squared. And this is our third and final Pythagorean identity. Again, you don't have to memorize it as long as you know the big kahuna. All right? It's really easy to just work it out. I know how many tests that I've done that I just go through and take a second to derive it because I can't remember it. All right, so I do have a fun saying for this one too, which I didn't know until, I don't know, probably a decade ago now, but this one is cot plus 1 equals cozy, but you kind of have to say cot plus 1 is cosi, as in cosecant, okay? This is like a cot, like a camping cot. Cot plus 1 person, because 2 wouldn't be cozy in a cot. But cot plus 1 is cozy. So that's the phrase. So cot plus 1 equals cosecant squared. To remember that, but really, again, the big kahuna is really important. Now, these are all identities. Turns out you take a cosine squared function plus a sine squared function and add them together, this equals 1, which is really kind of interesting, okay? What we can do is rearrange at will, okay? Not that will, but a different kind of will. Okay. Rearrange at will. All of these equations can be rearranged because they are simply just equations. So I can look at cosine squared plus sine squared equals 1, and I can rearrange it. I could get cosine squared theta all by itself. How do I get that alone? What do I have to do? Subtract the sine squared. So if I subtract the sine squared, it would be 1 minus sine squared theta. I'm sorry, you can't see that. All right. What about cotangent? Let's say I want to get cotangent squared all alone. What would I have to do to get cotangent squared alone? Minus the 1 to the other side. So that'd be cosecant squared theta minus 1. Okay? So all of these can be rearranged to suit our needs. Do you have questions for me?
No.
Okay. What? No? Okay, good. All right. Okay, so not too terrible there. So here's what we're doing today. We are simplifying to a single trig function with no denominator. I'm going to write down my big kahuna. Cosine squared theta plus sine squared theta equals 1. Just like to have it written down because I can just see it a little bit more easily. So there's like a million ways to do this. Ooh, you know what else? These are squared as well. I think I want to write down my other things here too. Let's see. What was my special saying? 1 adds a tan by the secant squared theta. Okay, and then what was the other one? Cot plus 1 equals cosecant squared theta. Excellent. Okay, so lovely that you even have those in your head already. That's great. So what we're doing with identities is we're taking something and replacing it with its equivalent. So I'm looking at my denominator here, secant squared x minus tangent squared x, and I have an identity with both of those things. Can I rearrange these a little bit? Could I? Like, what is secant squared x minus tangent squared x equal to?
1.
It is equal to 1. Why? Yeah, because if I move that tangent over there, that's going to give me 1 equals secant squared, well, theta, minus tangent squared theta. But I can replace theta with x. It doesn't matter what I use. Okay, so that means that secant squared theta minus tangent squared theta is really just equal to 1. So that whole thing just gets replaced with a 1. It is identical to a 1. Boy, that cleaned up pretty good, didn't it? Okay. Now, what about cosine squared? Cosine squared minus, is it sine squared? Negative sine squared. Yeah. So tricky, a little bit tricky. Cosine squared minus 1, if I bring my minus 1 over here, I have to move the sign to the other side as well. Cosine squared theta minus 1 would be negative sine squared theta. So we do have to be a little bit careful sometimes. Does that make sense to you? All right. So cosine squared minus 1, I get to replace that with negative sine squared theta. All right. Do I have a single trig function with no denominator now? Negative sine squared. Oh, sorry. It's not a theta. It's an x. I apologize. All right. So there we go. There's our single trig function with no denominator. All we're doing is taking things out and replacing them. Giving up? Yeah? Giving up right now? Yeah? Okay. This one, we have, first of all, I'm looking and I see that I've got a GCF here. All right, what do they have in common? A 4, sure. So I'm going to pull out a 4. If I take out a 4, what's left behind? Minus, I keep writing thetas. All right, minus cotangent squared of x. Good, good, good. All right, let's see. So cosecant squared x minus cotangent squared x. Going back up here, there's a cosecant and a cotangent. Oh, way back up here. Yeah, we can subtract that cotangent to the other side. All right, so cosecant squared minus cotangent squared, what does that equal? Just 1, yeah. That becomes just simply 1. So it's just 4. Crazy. All right. All right, we've already done this one. What's cosine squared x minus 1? Negative sine squared x. All right. And then that's over sine squared x. So what's left? Negative 1. Yeah, what's that? Interesting how it was so complicated and it can just become so very, very simple. Okay. Last things. Again, simplify to a single trig function with no denominator. General rule of thumb here, it's a pretty good idea to just mostly, well, am I going to do that here? Well, so here's what's hard about identities, simplifying identities. You can do it a multitude of ways. There's like 7 different ways that I could simplify this. One is like super easy and one is a little bit harder. But I think in general, I'm going to go with use sine and cosine. That's sort of the rule of thumb most of the time. I did it differently on my own paper. So I can rewrite tangent as sine over cosine. I was going with sine over cosine. Sine theta over cosine theta. And I can rewrite cotangent as cosine over sine. Yeah. And again, there's like 7 different ways you could do this. So I don't like dividing by a fraction. What do we do instead? Multiply by the reciprocal. So I have my sine over cosine times, I'm going to flip that, sine over cosine. How do you multiply fractions? Straight across. So sine times sine is sine squared theta, and cosine times cosine is cosine squared theta. I need a single trig function. I don't have 2. Yeah, good. Sine over cosine really is just tangent squared theta. Now, there was definitely a simpler way to do that. You could just rewrite it, change that one to 1 over tangent, and do the same thing. I probably should have done that, but let's stir things up. Cosecant. Let's rewrite cosecant. What can cosecant be rewritten as? 1 over sine. This one is times cosine. That's cosine over 1. Again, if I were to multiply fractions, I go straight across. 1 times cosine theta is cosine theta, and sine times 1 is sine theta. And what is cosine over sine? Cotangent. And that's it. Not squared this time, no. Almost done. I hear the sighs of fatigue. What? Oh, they are. Sorry. I meant to, I'm gonna work. Let's just cross that one off and let's just do this problem. Sine squared theta times cosecant theta. Well, I already had it written on here. I knew. Let's just do D. So I'm going to rewrite cosecant theta. What can I rewrite cosecant theta as? 1 over sine. Good. And again, We're going to multiply our fractions straight across. So what do I get in the numerator? Sine squared theta over sine theta. And what does that? Yeah, it is. It's just sine theta. This is, you think about it as sine theta times sine theta. One of them is going to cancel out. So that's it. Okay? You good? Delta math? Oh, delta math. Hiya. Oh.